All right, you finally made it to the midterm review. I don't believe there's any homework due this week. Just take the week to kind of review stuff, get yourself ready for the midterm. I want you all to be successful. Keep in mind that during the midterm, you're able to use your calculator or any of the resources that you have available to you. Um, Really, there should be nothing that tricks you. There's 100 questions. There's some math. Um, just take the time to do the review though. And during this review, I'm just going to break it down section by section that we've covered so far and what you need to know throughout those sections. That way you're not left figuring out what it is you need to study in order to be successful in your midterm. So with that, let's get started. Okay, so sources. We covered a lot of topics in sources. Um, let's see what you're going to need to know. You want to know the characteristic differences between surface water and groundwater. That'd be like the temperature swings versus a more stable temperature, the water quality characteristics. You're going to want to become familiar if you're not already, just kind of breeze through it again, and just get a better idea so that way you're not having to study this stuff, during the midterm. Know the different types of dams. There was the four different types. There's arc, buttress, embankment, and gravity. Know the different layers of the thermal stratification. So there's epilimnion, metalimnion, and hypolimnion. Know the different types of aquifers. Let's see. Know the components of a well. There's many different components that we've discussed, but you know, become familiar with those. Briefly go over that stuff, and you should do just fine there. Know the difference between emergency and alternative water sources, and know groundwater math, right? So those are the need to knows for water sources on the midterm. So with that, let's do a math problem. So you have a well A that contains 48 parts per billion of arsenic and is flowing at 450 gallons per minute. Well B contains 52 parts per billion of arsenic and is flowing at 275 gallons per minute. And well C contains 20 parts per billion of arsenic and is flowing at 600 gallons per minute. What is the resulting concentration of arsenic? Give you a second to pause this if you want to try and solve it for yourself. And with that, let's solve the problem. Okay, first thing we got to do is, figure out, well, you want to have the formula. If you're not familiar with them, go ahead and write them down. It'll help you place the correct units in the correct location to be successful in solving the problem. So we got to take the sum of total production gallons per minute, which you have here. You get the 450, you've got the 275, and the 600 gallons per minute, and you want to multiply each of those individually by their parts per billion, and then divide that by the total gallons per minute. So in this case, it's 1,325. And then you want to um, you solve for those individual ones to make it easier. So that would leave you with, if you multiply 450 by 48, you get 21,600. 275 times 52 equals 14,300, and 600 times 20 equals 12,000. You divide those by 1325, and you get 35.7 parts per billion. So that's the answer for that one. All right, let's move on. The next section that we covered was pipes. So you want to know the different types of pipe. I believe that's one of the earlier slides in that presentation. So if you want to go back and review that, you'll see the crown, the soffit, the belly, the spring line. So become familiar with which one's which. Know the difference between the types of pipe. So we covered, multiple different types of pipe. Just be kind of familiar with the different characteristics. So there we go, pipe characteristics. And then know the methods for preventing cave-ins. We talked about shoring, sloping, shielding, Scaffolding is not one of them. Know the process of putting a main in service, right? So you need to you got to pressure test it, you have to chlorinate it, you have to pass back teas, all of these things need to be done before placing a main in service. And then there's this, know your dosing calculations. You guys should be pretty familiar with this one at this point. So let's go ahead and do one. All right, so you got your dosing calculator, right? I personally like the pi method, but again, if you like to do things linearly, by all means, stick with that method. I've just had a lot of success with this because it's just like a plug and play, right? So for your X, typically you're going to put in either your million gallons or you could populate that with your parts per million. And then for Y, you would do this, the same, but the reverse of whatever it was. And then 8.34 is the weight of 1 gallon of water, so that's going to be a constant. Your Z is your pounds of chemical, whatever it is you're dosing at. And then if there's a percent solution, you want to divide that by the decimal point, whatever that number may be. And just keep in mind that if that's what I'm asking you to solve for, that number should be much larger. Whatever that percent or, the percent or pounds of that solution is, should be larger than whatever the figure is that's in the Z location. Valves. All right. So yeah, there's plenty of different valves that we covered. We covered butterflies, gates, sidewinders. Just, go through those. Know the classifications. The use of the valves, right? If it was an air vent, why do we use an air vent? Why do we use a blow off? Are you using a globe valve? Like, because that's the kind of valve that you want to use if you're having to throttle flows. Know how to calculate force. All right. And with that, let's calculate some force. Okay. You have closed a 36-inch Sidewinder valve. On one side, you have 0 psi, and on the other side, you have 136 psi. What is the force against the closed surface area of that valve? I will give you a second to pause this if you want to take a stab at it yourself before you follow along in the presentation. And with that, let's do it. Okay, so force equals 0.785 times diameter feet squared times 144 inches squared per feet squared times psi. So if we convert inches into feet, you're going to get 36 inches divided by 12, you get 3 feet. So then we insert that number into our equation here. So you get 0.785 times 3 feet squared times 144 inches squared per foot squared times the 136 psi, and you get 138,361 pounds of force on that one side of that valve. So, do you think it will be easy to open this valve if you were in this situation? Not likely. All right. And again, this is why you have a bypass valve installed on a Sidewinder, just to help equalize forces or pressures on both sides of that valve to make the operation of that valve easier. All right, we did a lot of math. So know your math. Pay attention to your units, right? So make sure that you're tracking your correct units. A lot of people will make mistakes by uh, inserting or having the wrong unit or not paying attention to their units. But at this point, I don't think I'm going to cover any math for you in this review. But if you want to do any math or you have questions about any of the math, please feel free to reach out to me or someone else in the class. Definitely want you guys to be successful. So use your resources. All right, we covered safety. There's a lot to know in safety, but you want to know the division of responsibilities. So that was the employee, the supervisor, and the manager. You want to know the regulatory requirements. Some of that stuff will be pretty, there's not a deep dive, but it'll be pretty basic. OSHA, some of the OSHA standards and stuff. No lockout tagout. You want to know the confined space, like entry procedures, how many uh, people are typically at a confined space entry. So you've got the entrant, you've got the attendant, and you got your supervisor. Know the injury, illness, and prevention program. Like every agency should have this one. This is just real high level stuff here. So it's nothing in specific, but just be familiar with it. You want to know HAZCOM. We touched on that in that presentation, so just kind of breeze through some of this stuff. And then, of course, the dangers of asbestos pipe. It can lead to mesothelioma. Unfortunately for this section, there is no math, so you don't have to worry about that for safety. All right, administration and record keeping. You want to know utility management, the Safe Drinking Water Act, planning, like we talked about, long-term, short-term. Know the different types of capital. Those are revenue sources that are used to fund projects. Know the revised total coliform rule, the disinfection byproduct rule, the lead and copper rule. And when I say know these things, I'm saying like, be familiar, like, how long are records retained? What are the sampling requirements? Is it lead? Is it copper? Be familiar with those numbers. Uh, record keeping requirements, like what's some of the security aspects to maintaining those records? How do I find the documentation that states how long I'm supposed to maintain records for? And unfortunately, there's more math, right? So let's do a problem real quick. All right. You have a pump that has been in operation for tens of thousands of years and operates at 1 billion gallons per minute with a total dynamic head of anyway, right? Um, anyway, all of that is useless information when you read the problem, but when you take a state exam, they like to throw that stuff in there. So I just made fun of it. Okay, so the pump uses 6,135 kilowatt hours per month at 0.079 kilowatt hours per kilowatt hour, excuse me. If the pump efficiency is 65%, how long will it take to pay for a new pump rated at 91%? That costs $13,425. So if we calculate out the old operating costs, you get $484.67. With the new pump operating costs, remember you need to divide that percentage, or the efficiency percentage of the old one divided by the new one, and then multiply that by the kilowatt hours per month times the cost of operating that, and you're going to wind up getting $346.19. So now we have to subtract the old from the new, and then you want to multiply that by 12 months in a year, and you wind up getting $1,661.76 per year savings. However, we need to figure out how long will it take to get that ROI. So then you take the cost of that pump and you divide that by your annual savings, and you wind up getting 8.08 years to get your ROI. So with that, that concludes our midterm review. Again, if you have questions throughout the week, reach out to me, let me know, or use your resources. Everything that you're going to find on the midterm, you have experienced in this class at this point. Like I said, there's no curveballs, there's no surprises. Um, I truly do want everyone to be successful in the class. So, let me know if you need help with anything. Remember, how, or I think one thing that I didn't recall seeing, oh, I guess I talked about it a little bit was, pressures, right? Know the difference on how to calculate out PSI versus total head. So with that, let me know or let anyone know if you got any questions, and good luck.